So this is lesson 2.1.5's homework help, and there are quite a few problems that are tricky on this one. So you'll see me using Desmos and Texas Instrument calculators to help you get through the concepts, but you'll also be seeing me do the algebra work. So hang in there and do the best you can. We'll follow along. Here we go. Okay, so on 2-69 here, this is a parabola problem. It says a fireboat in the harbor is helping put out a fire in the warehouse on the pier. The distance from the barrel of the water cannon to the roof of the warehouse is 120 feet, and the water shoots up 50 feet above the barrel of the water cannon. Sketch a graph and find an equation of the parabola that models the path of the water from the fireboat to the fire, and then give the domain and range for which the function makes sense in relation to the fireboat. I'm just going to really quickly graph out a very, very rough parabola of this and show you that this is what we're looking for. So because of the 120 feet, I'm going to have 60. I'm putting it right over the point of origin. So it's going to be 60, 0 as 1 point. And this is going to help me with my list later. And again, this is very rough. Negative 60, 0 for my other intercept. And also this is not to scale, so forgive me on that. All right, and then our max is going to be at 50 feet. Oops, so that should be, hang on. I got to get that looking better. Okay, it's going to be 0, 50, okay? And then what we're going to use is we're going to use Desmos and the TI to help us come up with the equation that forms that particular graph. So let's just jump into listening to both videos and then a follow-up on what the actual equation is, the final equation. Okay, so on 2-69, this is the diagram that they've got, and I want to kind of zoom it in. Let's see here. There we go. So it's not so high up. All right, and they've given us some sliders to help us place the position. Those aren't really going to impact the equation completely, except for the horizontal, because we'll end up on the y-axis. But let's go ahead and get these to 0, because I want to make sure I get this placed. So I've got my horizontal, so it's on my axis. It doesn't quite look like it, but this is just a sketch going on top of a graph. So, and then I'm also going to put this at 0, although that is not what happens with our vertical. So let's take a look at this. Okay, so I'm at 0. All right. Now, I pointed out to you on the graph before that you would put it at, you've got it going 120 feet total. So that means 60 feet of it is going to be on the left and 60 is going to be on the right. So we're kind of, we're going to come up with an equation just from looking at this. So the first thing I'm going to do is I'm going to put it in graphing form. And I'm going to say y equals, and I'm just going to use the vertex form. And I know I have it at, and I'm putting 0, even though I don't need to. Wait, I didn't mean to hit that. Okay, there we go. And squared. All right. And then I'm going to put it at plus 50 because that is our maximum. And then you see that the parabola is opened upward. Well, we need it open downward. So I'm going to go ahead. The only thing I need to do here is change it by putting a negative. So now it's upside down. Now, we don't want it to get skinnier, so we don't need a stretch, but we do need a compression. So that means we need to have a fraction out here. So I'm going to start with 1/25 and see what happens, okay? All right, well, that gets us closer and closer, but I want to hit 60. I want to get to 60. All right, so let's hit 60. Pretty darn close. So let's hit 70. That to me is perfect. So what I'm going to do right now, that looks really good. We are going to go to the TI and get it exact, but we'll see what that does. But let's go ahead and put the points that we had on the slide into the graph so we can see how well we did. All right. And so now what I'm going to do is, because I want them on the same table, I'm going to come up here and get a table. And I'm going to put in our negative 60, 0. And then our 60, 0. And you see that it looks really, really close. We're right on the 0, 50. These are very close points. So now we're going to go to the Texas Instrument calculator. So let's just bring that up. And let's go to our lists. And we do that by hitting Stat, and then we're going to edit. And we're going to put our 3 points in. So we know that our first point on the list 1 is going to be 0 because that's for our vertex. And so I'm going to hit enter. And then we have negative 60, enter, and we have 60. Okay. Then we're going to go to list 2 and we're going to hit 50 because that's our maximum. And then we're going to hit 0 because these are the zeros for the equation. Then remember what we do. We go to stat, then we scroll over to calc, and then we hit 5 because of the quadratic regression. Remember, this is going to give us our quadratic equation, our A's and B's and C's for this particular equation. So I'm going to scroll down to where it says calculate. All right. And I'm going to hit enter. And look at that fraction. A equals negative 0.013 and then 1, 2. There's 6 eighths. Okay. And we are going to put this into Desmos. So I'm just going to head and notice the B is 0. And notice our C is 50. And that is because there is no horizontal translation. There's only a vertical shift up. But our A means we have quite a compression here. So let's get rid of that for now. And then let's come and put that equation in and see how well we did. Okay, and I'm going to go ahead and type in. And the only thing I really need to worry about changing with regard to that graphing form is the A. So I'm going to go ahead and put it in because it's crazy. 0.013 and then 888, and that's because it's been rounded. And then we'll do the X, and this time I'm going to leave out the 0 because you don't need that, squared, and then plus 50, and see what we did. Look at that. Look how close we came with playing with our negative 1 over 70. So if I bring up the calculator, let's take a look at what negative, I'm going to go out here and hit second quit. And I'm going to say, what is negative 1 divided by 70 to see how close we came. All right, and then the other we had was negative 0.013888889. Okay, so that's pretty darn close. Anyway, there's your equation. There are your points. We did a pretty good job of guesstimating, so to speak, within Desmos. But remember, you can use quadratic regression in the TI to make it more exact. And here we go. Okay, so on this problem, I'm going to, it says draw the accurate graphs of those 3 different equations up here. Okay, and then on the same set of axes. So I have done that using Desmos. I also have labeled them here so you know which ones are which. So the black is our first one, and you can see the arrows going to it in the red and the blue. It says in the equation on y equals 2x plus 5, what does the 2 tell you about the graph? The 2 tells you the slope. On a linear equation, we can go up 2 over 1, up 2 over 1, up 2 over 1. That tells us the slope. So that's also in y equals mx plus b form. So that should help you remember that 2 actually is a slope. 5 is our y-intercept, and you can see that's where all of them intersect. Okay, and so they all intersect there, but then it says, is the 2 in y equals 2x squared plus 5 also the slope? This is not a linear equation, so it does not have a slope. The 2 is our a, and it would give us a vertical stretch, but it is not considered slope. It is just considered what helps vertically stretch or compress, because as you can see up here, we have a 1/2, that is compressed. We have a 2, that is a vertical stretch. The parent function would be somewhere in between, okay? And that answers 2-70. Okay, so for this particular function, you'll not see me do a whole lot of drawing, but it says do the sides, or think about how you might sketch a parabola on a graph. Do the sides of a parabola ever curve back like the figure at the right? And no, they don't. So here's the reasoning behind that. If you notice here, I've drawn vertical lines. Now, they're not perfectly straight, but you get the message. If you have a diagram and you draw a vertical line through it and hits it in more than one spot, that means it's not a function. Well, all parabolas and quadratics are functions. And you can see that from here. If I was to draw a vertical line through any of these, it would only hit it at one spot, okay? So these are all functions. This is not a function. In addition, on part B, it says, do the sides of the parabola approach straight vertical lines as shown in the figure at right? No. They don't have asymptotes either, because the domain of a quadratic is all real numbers. There is not a single x value that will cause an asymptote, okay? Inverse linear or some of the exponentials, yes, but not this particular problem right here, okay? So therefore, there are no asymptotes. And in this situation, the only thing that's different is you've got one parabola that is pointing downward, and that would be a different range because it would be 0 to negative infinity or negative infinity to 0, depending on how you look at it. And then the same thing for up above. These are all opened up, so they're going to be from 0 to positive infinity as far as y. Okay, so that pretty much answers all the questions on 2-7-1. So on this particular problem, it says find the equation of an exponential function that passes through each pair of points. So we are using the equation y equals ab to the x. That's our exponential equation, okay? So what I'm going to do first is I'm going to solve these algebraically first. I'm going to walk through part A, then show the work for part B, but then we're going to go into a video of exponential regression to prove that our equations are correct. So first things I'm going to do is I'm going to take 2 and 9, and I'm going to plug them into the equation and solve for A. So this is what I'm going to do. So 9 is my y, a, b to the second, okay? Now what I'm going to do is I'm going to divide by b squared, okay? And that gives me 9 over b squared equals a, okay? Then I'm going to do the same thing with the other point, 4 and 324, okay? And this is kind of like a systems of equations, so to speak. We're going to use this information, plug it back in, and solve. All right, so then I have 324 equals a, b to the fourth, okay? Then I'm going to divide by b to the fourth and b to the fourth. And so that means 324 over b to the fourth will equal our a. Well, now that they both equal a, that means they equal each other. So I'm going to solve for b. All right, so 9 over b squared equals 324 over b to the fourth. I am now going to use cross multiplication. So that means I'm going to have 324 b squared equals 9b to the fourth. Okay, so what I know I can do is divide by b squared because I'm going to be able to cancel it out on the right and cancel it out on the left and reduce on the right. So I'm canceling that out. And then this goes away and this becomes 2. So then that means that 324 equals 9b squared. So now I need to divide by 9. And so 324 divided by 9 is 36. That means b will equal 6. Okay? So I've got to plug that back into the equation. And I will use the 9 over b squared, which equals a. So we have a equals 9 over b squared. So that means a equals 9 over 36, which equals 1/4. Okay? So that means our equation is y equals 1/4 times 6 to the x. That's our equation, and we will check that out in the calculator in just a moment. Okay, so on this particular problem, you'll see that I've pretty much cleared this calculator down to doing not much of anything at this point because I haven't entered anything. And we are asked to do 2 different problems where we're given 2 points and we have to come up with an exponential equation for it. I just proved algebraically how you could do that with part A. And so now we're going to get into the TI and show you how you can find that equation to confirm your work within the TI and using exponential regression. So what I'm going to go ahead and do is I'm first going to populate my list because we don't have that done yet. So I'm going to go to Stat, then I'm going to hit Enter because I want to edit. And list 1 will have 2, and then 4 for my x's, and then, oops, let me hit Enter there. Then I go to list 2, and it's going to have 9 and 324. Okay, so those are the 2 points that we're going to use. Then what I want to do is I want to make sure that the points are plotted so that when I enter the equation, I can see if it works by the fact whether it goes through the points or not. So I'm going to hit second stat plot, which is up here. And I notice that this is the first one. That's the one we're going to use. The points are off. So I'm going to hit Enter. I could hit 1 also. I'm going to change it to 1. And so now it's going to be on, and it's going to mark those points in green, and then the points are going to look like this. You could change them to whatever you wanted to here. But it also has list 1 and list 2 here. You could also do it where it's a graph that goes through it, or a bar graph, but we're just doing a scatter plot at this point. And then I'm going to hit Enter, and I'm going to go graph, and I want to make sure. Now, I don't think I'm going to see both points. Nope, I'm not going to see both points, but that's because my window is at zoom standard, okay? Well, I know, I can see right now that 29 hits, but I need it for 324 to be seen. So I'm going to come up here, and I'm just going to go ahead and put 350. And that's the only one I'm going to change right now. And we'll see what it looks like. We'll see if we can see both points. All right, we see both points now, okay? And what I'm going to do now is go and hit Stat, Calc. I'm going to scroll over. And you don't see exponential regression here, so we're going to scroll down here because I do believe it is 0. Awesome. So we're going to hit 0. And you'll see here it's got list 1, it's got list 2, and we're going to scroll down to calculate to get the values that we want. Okay, it's going to calculate the regression, and it's going to say that my A, which we came up with 1/4 and 6, so this is good. So my A is 0.25, and my B is 6. Okay, and so what we're going to go back now and do, using this information, we're going to go to the y equals, and I'm going to type in 0.25 times 6 to the x. Oops, that's not to the x, hang on. That's not what I want either, sorry. All right, I want that to be x. There we go. All right, now I'm going to hit graph, and it should go through both points that we plotted. Very good. There you go. That's our exponential regression way of calculating to make sure we have the right equation. Okay, and that will finish off part A, but we'll do part B in a minute also. Okay, so we're going to solve quickly algebraically part B like we did part A. And so I'm just going to go ahead. Remember, we have this equation right up here. Let me get that. And okay, we have that equation. Sorry for moving the screen. And I'm going to go ahead and plug in what we know. So I'm going to use the first point because I want to show you something with exponents too. So 40 is my y equals a b to the -1. Okay, I'm going to divide by b to the -1. Okay, so a, let me kind of drew that a little bit too early. All right, so a will equal 40 over b to the -1, which is the same as a equals 40b. Okay, so then what I'm going to do is I'm going to come over here and I'm going to plug in the 12 equals a b to the 0. Okay, now b to the 0 is going to equal 1. So we're just going to have it as 12 equals a. So now we have a equals 12 and a equals 40b. So we're going to set them equal to each other. So 40b equals 12. So that means b equals 12 over 40, which is 3 over 10. So the equation that we have right now is, because we know that a is 12, is that y, let's just write it over here. Y will equal 12 times 3/10 to the x. So let's go to our Texas Instrument and figure out if that is correct. Here we go. Okay, so on this particular, this is part B, and so we're just going to jump right in and go stat, edit, and we're going to put the points in. We have a -1, that's 1x, and then our next x is 0. Okay, and now we're going to go back up to the list 2, and we're going to put in 40, and our next y is 12. Okay, so now we have our 2 points. I'm going to go to second stat plot to make sure it's on, which it's not. And I'm going to change it to 1, or to change it to on. Then I'm going to scroll down because I would like it to be green. So I'm going to go ahead and just scroll till it hits green. Awesome. Okay, so now we have our points. And we're going to go check and see if they're graphed. I don't see them. Probably because we have things outside of the window. So we're going to check our window. Now we know that 40 is our top. So I'm just going to go ahead on my Y and hit and say 50. Okay. And then I'm going to, the lowest I have is -1. So I'm okay on the X's. So I'm going to go ahead and hit enter. And then I'm going to hit graph. And you can see both points there. Now, this is ugly because I didn't put a smaller scale or different scale. So let's change that. I'm going to go to a scale of 5. Just so we don't have to look at all that. It looks like fringe, looks like hair, and it's like, yuck. Okay, that looks a little bit better. All right, so now what we're going to go ahead and do is we're going to hit stat and then scroll to calc, because again, we're going to go and find the exponential regression, and that is 0. But I want to make sure, since it's only the second time we've done it, that you understand that. I have list 1, list 2, and then I'm going to scroll down and I'm going to calculate. And we're going to see what our values are. Okay, awesome. We already knew A was equal to 12 because of the way we solved it. And we knew that B was 3/10 because of the way we solved it, because here it's 0.3. So our equation is correct. So now let's go back to the y equals and plug in our equation. So it's y equals 12. And then in this case, because we have a fraction or a decimal, I'm going to go ahead and put it in parentheses, 0.3. And that's to the x power. So we're going to square that, or not x square it, but put it to the x. That's our exponential. Then we're going to hit graph and see if it goes through our 2 points. Perfect. Also, that means that we did that correct. We plotted our points correct. We also solved it correct algebraically. And that ends this particular part of the video. Okay, so I got hiccups on the last one, and I hiccuped so many times I thought, I just better restart. So I was like, whatever. All right, so in this particular problem, I've already worked through all of the equations just because it's something you've done before, so you really didn't need to be taught anything specifically. But you will see that on the first one, 2x squared plus 3x minus 5, I set it equal to 0 so that I could solve for the 2 intercepts for x, the 2 solutions or zeros or whatever you'd like to call them. Then down below, I plugged 0 in for x and solved to get what the y would be. So I'd have my y-intercept, which is 0, -5. And you can see that on the graph, the picture of the graph that I put over here. The second one's a little different. The second one, I still set it equal to 0 to solve for x, and that gave me 2, 0, which was great. Okay, but the problem I have here is there is no y-intercept, but you can prove that algebraically by plugging a 0 into the x. Then you get a non-real number because it becomes the square root of -2. So there is no y-intercept on that. And again, that is verified by looking at the graph of that equation from Desmos. So that ends 2-73. Okay, on this problem, I'm going to do most of it just by showing you how to graph on Desmos, only because it's easier, since it's neater than you seeing me graph with pen and pencil and trying to stretch points and put them together. I'll just go ahead and show you on the graph how to do it. And then we'll figure out what their important locator point for a parabola is, the vertex. But I wanted to show you something. This particular problem is already in vertex form. So that'll be fairly simple. This one sort of is as well. This is like saying y equals 3 times x minus 0 squared plus 5, because there is no b term, okay? All right, so that'll help a little bit. So let's just jump into Desmos and see what these graphs look like. so we can verify what each locator point is. Okay, so this one is asking us to find the locator point, which I think is really funny because we're just looking for the vertex, which we can pretty much answer from the equations, but they want us to graph these two equations. So let's go ahead and jump in. I've listed all of the equations here first, and we talked about on the slide how this 3x squared plus 5 is similar to this vertex form, which is 3 times x minus 0 squared plus 5, and they are. So let me just go ahead and unmute this, and you'll see that they're the same equation because the purple went right over the green. But let's go ahead and mute the purple because that's not what we're actually checking, and then let's go ahead and use the information we have from these and start plotting points, okay? So I'm going to go ahead and plot the vertex for the first one, and that is 0, 5. Okay, so there's 0, 5. And then what I'm going to do is I know now that my axis of symmetry is x equals 0. Okay, oops, I did x minus, sorry. X equals 0. All right, so, and that's because this particular value of the y refers to the minimum in this case because this opens up, and this 0 refers to the axis of symmetry for this particular parabola. So now what I'm going to do is I'm going to make a table out of these values, and I'm going to plug in values that I think fit along the lines of this particular equation. So I'm going to go a little to the left and a little to the right. So I'm going to go with 1. So I've got 1 here. So I'm going to type in 1. And 1 squared is 1, times 3 is 3, plus 5 is 8. Okay? And so I'm 1 away from this axis of symmetry, so I'm going to go 1 the other direction. So I'm going to say -1. So it's -1 and 8. Okay, and then I'm going to try one more. I'm going to do 2, and we'll see if it ends up off the screen or not. So if I plug 2 in, 2 squared is 4. 3 times 4 is 12, plus 5 is 17. So that's going to be 17. That means I'm 2 away from the axis of symmetry, and so I'm going to the other direction, so that's -2, 17. Okay. All right, and so now I'm just going to go ahead and hit this equation and see if I graphed it correct since we already have that information there. Okay, perfect. All right, so we did that completely correct, and now we're going to move on. Our locator point, or our vertex, so to speak, is 0, 5, okay? And I'll go here and I will put in, watch, 0, 5, and I will label it as the locator point. Okay, 0, 5. Okay, that takes care of part A. So let's just get rid of all of part A's information. If you need to, go ahead and pause this video, but I'm going to delete a lot of these others for right now. I'm going to unmute them, in fact. We'll just leave them muted. Okay, and then I'm going to also unmute these points because that we're going to do a different equation now. Okay, all right, now we're going to go to part B, which is right here, and this is the equation that it asked us to look at earlier. Okay, that's what it's supposed to be. All right, so now we're going to use that information. Let's get rid of everything around it, and let's graph it. Okay, all right. So we've got this equation, and so I know that my vertex is going to be 3. Let's put in parentheses, 3, comma, -7. So there's my point, 3, comma, -7, okay? I also know that my axis of symmetry is going to be x equals 3. Okay, so I've got my equation right here, my axis of symmetry to go between the vertex, because my maximum here is -7, and I say maximum because we have a negative in the front. Our A is negative, so it's going to be flipped upside down. So now what I want to do is I want to take this and make a table out of it, okay? All right, so I'm going to go a little to the left and the right. So I always like to hit 0. Let's try 0, okay? And let's see what I get. So if I plug a 0 in, 0 minus 3 is a -3, squared is a -9. well, it's going to be positive 9. And then that would make it a negative 9 minus 7, which is negative 16. Okay. Then I'm 3 away from the axis of symmetry, so I have to go 3 the other direction. So that means my other point is a 6 and negative 16. Okay. Then I'm going to try one more. I could come down here, but I'm kind of more interested in going in between. Let's do 1. Okay. So I'm going to plug in a 1. And if I plug in a 1, 1 minus 3 is a negative 2. A negative 2 squared is 4. Negative 4 minus 7 is a negative 11. So I've got negative 11 here. So I'm 2 away. So that means I have to go 2 across, and it'll be 5 negative 11. Okay, and then that ends my plotting of points. And then let's go ahead and just unmute this equation and see if we drew it correctly. Perfect. Okay, so now what I want to do is label this point, because this is our locator point. This is where we started, is 3-7. But I want to come down here and create that point. So it's 3-7. And then on here, I'm going to go ahead and put the label as the locator point. And that is 3-7. There you go. That's your locator point for the second equation. Hopefully that helps, and we're moving on. So this is the last question that we have for this review and preview. And it's actually pretty basic, but when it says that the g of x equals 20, it's actually saying that you should be substituting g of x itself and putting 20 in for it. And that's x squared minus 5. Then you're just going to solve. So we'll add 5, we'll plus 5. I'm sorry, that didn't make sense. X squared equals 25. And then you take the square root, and x is going to equal plus or minus 5. And if you check it on the graph, you will see that that's exactly what you would get, is plus and minus 5 on that particular graph. Okay, same thing on part B. It's going to look a little different. It won't be as nice and neat as plus or minus 5, but we'll take 6, substitute it in for g of x, and set it equal to x squared minus 5. We'll add 5. And then x will equal plus or minus the square root of 11. Okay. And that actually ends 2-75. It also ends the review and preview for 2.1.5. So if you have any questions, please feel free to leave them in the comment section. I'm happy to answer your questions. I will get back to you, I promise. In addition, I would love it if you would subscribe. We are trying to get to a point where we can monetize this channel. That's why these videos are free right now. And then also give it a thumbs up. And we'll see you on the next video. Take care. Bye.